Are you struggling to choose between ANSYS and SolidWorks for structural analysis? Both are powerful tools, but which one is better for your needs? Stick with me as we compare the key features of ANSYS and SolidWorks to help you make the right decision for your engineering projects. Let's start with ANSYS. Known for its advanced capabilities in finite element analysis, ANSYS is a comprehensive simulation tool used by engineers to solve complex structural problems. It's ideal for large-scale simulations involving different materials, complex geometries, and varying loads. ANSYS is specifically designed for simulation and analysis, making it a top choice for advanced engineering simulations. Whether you're analyzing static loads, thermal stresses, or dynamic responses, ANSYS provides the tools needed to predict the behavior of materials and structures under different conditions. Now, let's talk about SolidWorks. Unlike ANSYS, SolidWorks is primarily a computer-aided design tool used for designing 3D models. However, it also offers structural analysis capabilities through its simulation module, making it a great option for engineers who need a powerful design and analysis tool in one. SolidWorks is ideal for product design and prototyping, especially in industries like automotive, aerospace, and manufacturing. While its simulation capabilities might not be as advanced as ANSYS, it still offers solid analysis for common structural problems, such as static loads, vibrations, and stress distribution. So, what's the key difference? While both tools offer structural analysis, ANSYS stands out in terms of its deep, high-fidelity simulations and ability to handle complex geometries and materials. SolidWorks, on the other hand, is more accessible for engineers who need both design and basic simulation in one platform. ANSYS is your go-to solution when you need advanced simulation and high-precision structural analysis. If you're working on large-scale projects like bridges, buildings, or mechanical components that require detailed stress analysis under various conditions, ANSYS will provide the depth and accuracy you need. SolidWorks is perfect if you're focused on product design and need a design-first approach with solid analysis capabilities. It's ideal for engineers who want to streamline the design and analysis process, particularly for small to medium-sized parts and assemblies that don't require the advanced simulations that ANSYS offers. Another factor to consider is integration. SolidWorks is tightly integrated with other design tools and is often the choice for teams that want seamless collaboration between design and analysis. ANSYS, while offering more robust simulations, requires additional steps to integrate with CAD software, which might complicate workflows for certain users. So, which one should you choose? If you need high-level, complex simulations for large-scale engineering projects, ANSYS is the superior choice. But if you're designing products and want an all-in-one solution for both design and simulation, SolidWorks provides an efficient and cost-effective option. In the end, both ANSYS and SolidWorks are powerful tools, but they serve different purposes. ANSYS is the best for advanced structural analysis, while SolidWorks is a great all-in-one solution for product design and basic simulations. Choosing the right tool depends on your specific needs, project scale, and level of analysis required. Still unsure which tool is right for you? I offer consulting and training services to help you master ANSYS, SolidWorks, and other engineering software.